Typhoon Jangmi has an eye 130 kilometers across. That is bigger than central Tokyo. That is 3 times the diameter of a typical typhoon eye. And it is appearing on a Category 1 storm, which is something the operational forecast community almost never sees outside of much stronger systems. The storm is now 36 hours from a near-direct hit on Okinawa, and by the end of this video, you will understand why a Category 1 typhoon with the eye of a super typhoon is a fundamentally different hazard than its category number suggests, and why the whole world should pay close attention to this. Let's get into it. A Category 1 typhoon does not normally have an eye 130 kilometers wide. But that is exactly what Typhoon Jangmi has right now in the Philippine Sea. And it is exactly the reason the Joint Typhoon Warning Center, the Japan Meteorological Agency, and every operational forecaster across the Western Pacific Basin spent yesterday and overnight watching the satellite imagery more closely than they would for a storm of this category. Jangmi is the 6th named tropical cyclone of the 2026 Western Pacific season. International designation 06W. Philippine name Domeng. In Japan, simply Typhoon number 6. It formed off Yap on May 26th, reached tropical storm strength on May 28th, and crossed the Category 1 threshold at 6 in the morning Coordinated Universal Time on May 30th, with 1-minute sustained winds of 120 kilometers per hour. By yesterday evening, it had reached its current peak intensity of approximately 130 kilometers per hour, with a central pressure near 978 hectopascals. Those are textbook Category 1 numbers. What is not textbook is the eye. Overnight into May 31st, the eye cleared to 70 nautical miles in diameter, or roughly 130 kilometers across. The Joint Typhoon Warning Center bulletin issued at 3 in the morning Coordinated Universal Time today flagged it directly. That measurement makes Jangmi's eye the largest tropical cyclone eye recorded in the Western Pacific Basin since Super Typhoon Kong-rey came ashore on the eastern coast of Taiwan in October 2024. Kong-rey was a Category 4 super typhoon. Jangmi is a Category 1. The eye dimensions are comparable, the wind speeds are not, and that mismatch is the entire story. To put 130 kilometers in perspective, it is larger than the city of London inside the M25 motorway. It is larger than central Tokyo measured corner to corner. It is roughly 3 times the diameter of a typical mature typhoon eye, which generally runs 30 to 50 kilometers across. The strongest typhoons on Earth often shrink to pinhole eyes 10 to 25 kilometers wide at their peak. Jangmi has gone the other direction at Category 1 intensity. That is the structural anomaly the basin's forecasters are now bracing for. As of the most recent advisories, Jangmi sits approximately 600 kilometers south of Okinawa, tracking north-northwestward at 15 to 20 kilometers per hour under the steering influence of the subtropical ridge to the northwest. Maximum significant wave height in the southeastern quadrant has already reached 10.4 meters, or 34 feet, of open ocean swell radiating outward from a storm that has not yet made its closest approach to anything. The Joint Typhoon Warning Center forecast has Jangmi continuing its current heading for the next 24 hours, then beginning the recurvature northeast as the subtropical ridge migrates south and the mid-latitude westerlies expand southward. Closest point of approach to Okinawa is forecast for 9 in the morning Coordinated Universal Time on June 1st, which is 6 in the evening, Japan Standard Time. Tomorrow evening, local time, the eye will pass just west of Kadena Air Base. The eastern eye wall will sweep directly across the central part of the main island. Sustained winds at closest approach are forecast near 100 kilometers per hour. Central pressure near 982 hectopascals. After the Okinawa interaction, the storm accelerates northeast. It transits the Amami Islands on June 2nd, brushes southern Kyushu on June 2nd into June 3rd, runs along the southern coast of Honshu on June 3rd into June 4th, and approaches the Tokyo-Kanto Plain by June 4th. Extratropical transition begins on June 4th and completes by June 5th, at which point the system exits northeastward into the open Northwest Pacific. The remarkable thing about this forecast is the confidence. The cross-track spread, which is the standard measure of forecast uncertainty perpendicular to the storm's motion, is currently 120 kilometers at the 3-day forecast point and 185 kilometers at 5 days. For comparison, the 5-year basin average is approximately 175 kilometers at 3 days and 290 kilometers at 5 days. Jangmi's track is locked in tighter than typical. The European, American, Japanese, and consensus models are all converging on the same trajectory. The intensity guidance has converged equally tightly, with no rapid intensification aids triggering. That tight forecast envelope means one thing for the Japanese coastline. The storm is going to do what the consensus says it will do. The only operational variable still open is the structural one, whether the eye contracts in the final 24 hours of approach or whether it holds wide. The geometry of why a wider eye matters is straightforward, but it does not get the attention it deserves in most coverage of tropical cyclones. The destructive winds in any typhoon live in the eye wall, the ring of intense convection immediately surrounding the calm center. The eye itself is calm. The eye wall is the part that does the damage. And the eye wall is a ring, which means it has a circumference, and the circumference depends on the radius. A typical 30-kilometer eye has an eye wall circumference of about 94 kilometers. Jangmi's 130-kilometer eye has an eye wall circumference of about 410 kilometers. That is more than 4 times longer. The first consequence is geographic. The destructive eye wall, as the storm moves across a coastline, sweeps a swath of maximum wind impact across the ground. The width of that swath is set by the eye dimension. For Jangmi, the swath is roughly 4 times wider than for a textbook Category 1. More coastline experiences peak winds at any single moment. The geographic footprint of the maximum wind belt is wider. The second consequence is temporal, and it is the one that matters most for structural damage. For a storm moving at 25 kilometers per hour, the time it takes for the eye wall on one side of the eye, the calm of the eye itself, and the eye wall on the other side to pass over any single point depends on the eye diameter. A textbook 30-kilometer eye takes about 1.25 hours. A 40-kilometer eye takes about 1.5 hours. A 130-kilometer eye takes about 5.25 hours. To put that 5-hour figure in context, the comparable duration of peak winds at any single point during Hurricane Katrina's landfall in 2005 was about 3 hours. During Hurricane Andrew in 1992, which had a pinhole eye, it was less than an hour. Jangmi is going to exceed both of those duration figures for the population sitting directly beneath the eye wall path, despite being a much weaker storm by category. The eye geometry is the reason. 5 hours of sustained 100 km per hour winds is a fundamentally different hazard than 90 minutes. Cumulative loading on roofing fasteners, cumulative fatigue on metal panels and seals, cumulative stress on power lines and trees that bend through brief gusts but eventually snap under sustained loading. The structural engineering damage curve scales non-linearly with duration. Roofs that survive 90 minutes can fail at 5 hours. Trees that hold for 2 hours come down in 4. The longer the exposure, the larger the share of marginal infrastructure that fails. The third consequence is storm surge. A wider wind field pushes a wider swath of ocean ahead of itself, generating storm surge inundation across a wider stretch of coastline. The peak surge height at any single point depends on wind speed, coastline geometry, and bathymetry. But the geographic distribution of significant surge is determined by the width of the wind field. A Category 1 storm with a Category 4 eye distributes Category 1 surge across a Category 4 coastline footprint. Take all three consequences together: wider damage swath, longer duration of peak winds, wider surge footprint, Category 1 wind energy, distributed across the geometry of a Category 4 Super Typhoon. That is what Okinawa is going to experience tomorrow evening, and what Kyushu and the southern Honshu coast are going to experience over the days that follow. Yesterday afternoon, United States military installations across Okinawa Prefecture issued an internal status change. The status was Tropical Cyclone Condition of Readiness 2, the second highest level in a 5-step preparation framework. TCCOR-2 means destructive winds of at least 58 miles per hour are anticipated within 24 hours. Kadena Air Base, Camp Foster, Camp Hansen, Camp Schwab, and the Marine Corps Air Station Futenma all entered the condition together. In practice, TCCOR-2 means an active preparation checklist. Outdoor equipment gets secured or moved indoors. Aircraft on the flight lines either get evacuated to mainland bases or rolled into hardened shelters. Backup generator fuel stocks get topped off. Communications relays get verified. By the time the condition steps up to TCCOR-1 destructive winds, within 12 hours, the bases are essentially locked down with only essential personnel moving between buildings. This rhythm is institutionally familiar. United States Forces Japan has been operating in Okinawa since 1945, and the Typhoon Preparation Protocol is one of the oldest and most refined operational frameworks in the Pacific Theater. The bases execute TC core transitions 5 to 15 times per typhoon season. What is different about Jangmi is the structural geometry we just walked through. The preparation framework is calibrated to assume Category 1 winds, Category 1 duration, Category 1 footprint. The actual storm is going to deliver Category 1 winds, but for 3 times the duration, across a 4 times wider footprint. The framework still applies. The post-event reality may exceed what the framework was built for. The civilian population is preparing in parallel. 1.5 million people live on Okinawa Prefecture's main island. The Japan Meteorological Agency advisories have been stepping up in intensity since the storm was first identified, and by tonight, Japan time, they will be in their most active phase. Hong Kong-based budget carrier HK Express has already canceled 6 flights to and from Okinawa over the next 2 days, the first commercial aviation disruption. By tomorrow morning Japan time, most commercial aviation into and out of Okinawa will be suspended. Ferries are coming in. Ports are being buttoned up. Okinawa knows how to take a typhoon. The question this time is whether this typhoon is a category they recognize, or whether the structural anomaly produces something that exceeds the operational assumptions baked into decades of regional disaster planning. If you ask any operational meteorologist in the Western Pacific Basin what comes to mind when they see a tropical cyclone with an unusually large eye, they will tell you about Kong-rey. Super Typhoon Kong-rey made landfall at Changong in Taidong County, on the eastern coast of Taiwan, on the afternoon of October 31st, 2024. At landfall, it was a Category 4 equivalent, with 1-minute sustained winds in the 190 to 200 km per hour range. The eye measured 46 miles, about 74 kilometers across, with some microwave satellite passes earlier in the storm's evolution, resolving the eye to closer to 100 kilometers. The wind footprint was unusually broad. The pressure-wind relationship was unusual. The storm radius of strong winds extended outward more than 300 kilometers from the center. Kong-rey was historically significant in several ways at once. It was the first typhoon in Taiwan's recorded history to make landfall after mid-October. It was the largest storm by storm radius to hit Taiwan in nearly 3 decades, since Typhoon Herb in 1996. The landfall produced widespread damage along the eastern Taiwan coast storm surge inundation, sustained eye-wall winds documented at multiple stations holding above the Category 1 threshold. For hours on end, prolonged heavy rainfall in the mountainous interior, significant agricultural and infrastructure losses. The post-event analysis from the Taiwanese Central Weather Administration and the Joint Typhoon Warning Center emphasized that Kong-rey's structural footprint had delivered super typhoon damage geometry over an area more typical of a much larger storm. The reason Kong-rey matters for Jangmi today is that it is the most recent operational case study in the basin for how a large-eyed Western Pacific typhoon interacts with a coastline at landfall. The lessons from October 2024 are fresh in the operational memory. The structural diagnostics that forecasters use to recognize this class of storm are calibrated against the Kong-rey case. The communications language the Japan Meteorological Agency is using right now in its public advisories has been shaped by what the basin absorbed from Kong-rey. There is one important difference. Kong-rey was Category 4. Jangmi is Category 1. The wind energy is not comparable. Category 4 winds carry roughly 8 times the kinetic energy per square meter of Category 1 winds, because wind energy scales as the cube of velocity. Jangmi is not going to deliver Kong-rey scale destruction. The wind energy is not there. What Jangmi is going to deliver, and what the Kong-rey comparison illuminates, is the geometry. The spatial and temporal distribution of Category 1 winds across a Kong-rey style footprint. Same eye class, different intensity floor. Same lesson about how a wide-eyed storm engages with a coastline. That is why the operational community is paying as much attention to a Category 1 storm as it would normally pay to a much stronger one. Kong-rey was the lesson. Jangmi is the test. Okinawa is not arriving at this typhoon from a position of operational rest. The last 2 weeks have been unusually active for southern Japan, and not just in the atmosphere. On May 20th, the Japan Meteorological Agency recorded a magnitude 5.9 earthquake in the Kagoshima Prefecture Islands. Shaking was felt across the Tokara Islands in southern Kyushu. No major damage, no casualties, but strong enough to be the lead seismic story across Japanese national news on the day it happened. On May 29th, a magnitude 4.2 earthquake registered near Kumejima in the Okinawa Prefecture. At 230 kilometers depth, an intermediate depth slab event widely felt across the main island. On May 19th, the United States Geological Survey recorded a magnitude 4.4 earthquake about 84 kilometers northeast of Ishigaki at 101 kilometers depth. None of these events is individually destructive. The Ryukyu Trench is one of the most seismically active plate boundaries on Earth, and the descending Philippine Sea Plate produces hundreds of magnitude 3 and 4 events per year. By the standards of the basin, 3 moderate quakes in a 2-week window is well within normal background variability. The events are not connected to the typhoon. There is no peer-reviewed mechanism by which a deep-focus earthquake can influence the formation of a tropical cyclone 2,000 kilometers away. But the temporal stacking matters operationally, even if it does not matter physically. The same Japan Meteorological Agency regional offices that are tracking the typhoon are also processing the seismic data. The same public warning infrastructure is being asked to maintain readiness across 2 different hazard classes during the same week. The cognitive load on the regional emergency management apparatus is elevated. The cognitive load on the population is elevated. The compound observation is real. The coordinated event framing that has appeared in some online discourse is wrong about causation, but right about lived experience. For Jangmi specifically, the practical consequence is that the regional emergency management posture is more alert than it would be for a typhoon arriving on a coastline that had not just experienced 2 weeks of moderate regional seismicity. The shelters are open earlier. The pre-event communications are more frequent. The post-event damage assessment teams are pre-staged across a wider geographic distribution. The whole regional system is leaning forward. And on top of that posture, a Category 1 storm with the structural footprint of a Category 4 Super Typhoon is about to arrive. The next 40 hours are when this story actually happens. The most important signal to watch is the microwave satellite imagery. Microwave sensors on polar orbiting satellites can see through the upper cloud deck to image the structure of the eye wall directly, which is invisible to standard visible and infrared imagery once the storm builds enough cirrus canopy. If those passes over the next 12 to 24 hours show an inward contracting secondary eye wall, the storm is undergoing an eye wall replacement that may briefly intensify it as the new tighter eye consolidates. If the eye wall structure holds steady at its current wide configuration, the storm arrives on Okinawa as the structurally anomalous Category 1 we just walked through. The second signal is the Joint Typhoon Warning Center bulletin language over the next 4 6-hour cycles. Subtle shifts in word choice consolidating versus maintaining versus steady state will tell the operational community how the forecaster's reading of the storm is evolving. The third signal is the surface wind data from Okinawa weather stations as the eye wall approaches, which will provide ground truth on whether Jangmi is delivering the textbook Category 1 envelope or the extended structural anomaly. After Okinawa, the recurvature carries Jangmi across Kyushu's industrial corridor on June 2nd into June 3rd. The Kyushu cluster includes Sony's image sensor fabs at Kumamoto, the Taiwan Semiconductor Manufacturing Company joint venture facility JASM that began production in late 2024, and an active capital project pipeline worth $14 billion across 116 projects in Fukuoka Prefecture alone. The fabs themselves are typhoon-rated and will not be destroyed. The exposure is logistical port closures at Hakata and Kitakyushu, suspended aviation at Fukuoka and Kumamoto airports, just-in-time supply chains stretched thin for 48 to 72 hours, with secondary effects on the global semiconductor supply chain emerging over the following 1 to 3 weeks. By June 4th, the the storm reaches the Tokyo-Kanto plain. By then, it has weakened to tropical storm or severe tropical storm intensity and is completing extratropical transition. The Tokyo exposure is principally transportation, Shinkansen suspensions, Tokyo Metro precautions, Narita and Haneda flight cancellations. 38 million people in Greater Tokyo. By Friday, June 5th, the system has fully transitioned to an extratropical low and exited northeastward into the open Pacific. The aftermath is a several-day window of damage assessment, infrastructure repair, and supply chain recovery, and a post-event scientific analysis that will add the Jangmi case to the basin's institutional memory alongside Kong-rey. The question that will only be answered in the longer accumulation of years is whether Jangmi's structural anomaly is a single, curious data point, or whether it is the first visible signature of a 2026 Pacific season that is producing storms with configurations the basin has not seen in 18 months. The operational community is watching. The basin is watching. By the morning of June 2nd, Okinawa will have given the first concrete answer, and over the 4 days that follow, Kyushu and Tokyo will fill in the rest of the picture.